So this is the making sense with IoT, making sense of IoT data with the cloud. So if you're in the wrong room, then you can kind of check out now. But so my name's Ian Lewis. I'm a developer advocate on the Google Cloud Platform team. I'm based in Tokyo, Japan. So if you're ever out there, you can kind of give me a holler. I'm kind of into Python and Go and IoT and cloud and those type of things. So if you're ever interested, you can kind of hit me up on Twitter at Ian M. Lewis. I'm always on there, and I'm really willing to talk to you. And I'd love to hear from you about questions or things like that if you think of them later after the talk. So today we're going to be talking about IoT, and so IoT is the Internet of Things, obviously, and that enables you to get a lot more data about the world around you, and to be able to use that data to make better decisions about how to do things, improve things in your life, be more efficient, etc. So anything from smartphones to dishwashers to just connected devices that can measure sensor data like temperature or humidity or those type of things. And all of those are kind of creating all of this data, but that dealing with that data can actually be pretty hard. You want to actually be able to use that data later. So let's say that you have a great idea for kind of a connected device. Maybe it's a robot arm, maybe it's a sensor, maybe it's a dishwasher. So once you have this data or this new idea and it's collecting all this data, there's a lot of things that you have to kind of think about. You have to think about being able to connect the device to the network to be able to send the data. So establishing the connections, being able to do authentication, being able to manage that connection so that it stays live so you can actually send data. Then you have to be able to actually read the data from the sensors. You have to know enough about the hardware to be able to read the data from the sensor, to be able to then take it from in your program and actually be able to send it. Then you have to actually send the data over the network, and this can be done in a number of ways, but what if your connection is over kind of a wireless connection? Maybe it kind of goes in and out. You have to be able to deal with those type of connection issues that might arise. A lot of IoT related devices are on SIM networks or on 3G or that type of thing. You have to then be able to take that data and process it on the server. So you have to be able to figure out how to take that data, do some processing with it, and then actually store it. But you can imagine that if there's lots and lots of devices and lots of data coming in, you have to be able to handle all of that data coming in. And then you have to be able to actually store the data. So perhaps you have a large number of devices that are all generating data. You have to be able to store a large amount of data and to be able to handle that type of throughput. And then there's one last thing that I think is that people kind of overlook. You can actually get the data and store it, but then you have to be able to get the data out easily and analyze it and figure out, figure out how to make the decisions more smarter and be more efficient. So this analysis part is actually also really, really important. Being able to get the data out actually once you've stored it. So in this talk, I kind of want to go through how you would actually build an IoT application that is creating a lot of data and needs to process that data and store that data in the cloud. And so I'm going to kind of go through kind of a high level what this type of project would look like. What are the typical type of things you would see in an IoT application? And then eventually we'll kind of get down and actually start with a particular use case or a case study about how to actually architect an application. So some of the typical components in an IoT application. So here's an high-level architecture. You might have a bunch of devices. Say this is like an industrial application. I'm thinking mostly about industrial applications. A lot of people kind of think of IoT as kind of this connected home type of thing, and that's also relevant. But I kind of think of connected home as a special type of industrial use cases. So I'm going to speak in a very generic way about how to do IoT applications. But here's kind of a typical architecture. You might have a bunch of devices like in your home or in the in a factory or at a power generation plant or whatever, and they're all collecting data and then sending that data to a cloud service that can actually then process and store that data. And you might have the devices actually connected via just a cable to something like a gateway server that will actually send the data to over the network, or maybe over a short-term or a short wave like wireless, so that it's very works on a short distance. But then from the gateway you can actually send to the internet. So you might have a number of different types of setups, or the device itself could be connected directly to the internet. In that sense, it would kind of serve as its own gateway. So you can have a number of different scenarios, but as a general rule, like you kind of have this this gateway type of thing in your architecture quite often. And then when you kind of zoom in onto the cloud side, you might actually have a number of moving parts there. So you might have a front end that actually takes in the data from your device, and then some backends that actually process and store the data. So this might be kind of there might be any number of type of permutations of this type of background, but you might see, or this backend, but you might see these type of, but all architectures will tend to fall in this type of diagram. So now that I've looked at that, and I'll try to go in and fill the blanks about how you might, what you might actually use for the front end to back end for your application in a kind of a case study later. But next I want to talk about the actual types of data that you would have to send between devices and your service. So we've thought a lot about this, and one of the types of data that you would send is, or that you would have, is metadata. So these are device IDs or classes or models or revisions, those type of things about your device. And so this would be basically data that exists but doesn't really change very much. This is something that's very static for a particular device. And so, and it might give you the information about the capabilities of the device, but it doesn't really change. And it could be kind of free-form data. You don't really necessarily know exactly what might be in here. Depending on the type of device, it might be different. Also, state data. State data is very similar to metadata, except that this will kind of change fairly often because the device itself might change state or change location or whatever. So here we might have the status of the device, whether it's ready or it's in an error state or it's failing. You might have the status of each and every one of the devices or the sensors. So in this case, we have one that's like a temperature sensor that shows the current temperature and says that it's reading. And we might also have like location, if like say your device has a GPS or something like that. So this might be like updated like every minute or every hour or whatever, but it's kind of continually updated as the state changes for your device. Next is telemetry data. So telemetry is not really a commonly used word, but it's generally time series data. So this is the data that the kind of meat and bones or meat and potatoes type of application data that your sensors are generating. So basically over time, it'll generate read-only data that can be viewed as a time series. So maybe the humidity in the room or the amount of water flowing through a pipe or something like that. And then this is basically read-only, so it doesn't update. But depending on the number of devices that you have, you could very quickly get into very large amounts of data and a very high throughput. So you need to be able to handle that. And generally, you quickly have to apply big data type of strategies. The fourth type of data that I wanted to talk about was commands. So commands are things that would actually be sent to the device. So telling it to a specific device to like spin 360 degrees or spin 90 degrees or something like that, or run a self-cleaning cycle or do something. And these are generally not really, they have a specific type of properties in that they are not really represented as state data very easily. So when you send a command to a device, you want to actually have that command execute one time, and you want to be able to know if the device actually succeeded in running the command or not. So things like having the command, sending the command and having it actually run twice because of intermittent type of communication problems or things like that. Like if you told it to turn 90 degrees, if it actually ran twice, it would turn 180 degrees, and you don't really want it to do that. So you want these kind of like run only once type of semantics. It's also kind of temporal, so you want to have some sort of like TTL or something in order to be able to time out these type of commands. So that's some of the types of data and general like view of architecture for a IoT application. So next I want to talk about actually applying those ideas or applying the cloud to solve some of those problems. And so I'm going to do like kind of a case study and take a set of requirements and then actually try to create an architecture that will satisfy those requirements. So the requirements for this particular application that I'm going to do are pretty simple. It's just basically read some temperature data from a large number of devices for analysis later. And then we're going to manage the info and status of each device. So if we read these requirements, we can kind of see that the types of data that I was talking about kind of pop out. So here we have the temperature data would be our telemetry data. This is the data that runs as a time series. And then info about each device is metadata, and then the status of each device could be seen as state, right? So let's go and actually start trying to architect an application like this. So our RVR architecture is going to be pretty simple. I'm not going to use a gateway. Our device will actually connect directly to the internet. So in that sense, it's acting as its own gateway. And so when you look at it, the overall architecture, it looks very simple. But if you actually drill in, it can be a little bit more complicated. So there's a number of things that you kind of have to think about. So on the device side, you actually have to think about which device you're going to use, like how you're going to actually build the device, what sort of sensors you're going to have on the device, as well as the software that's going to run on the device. So you have to be able to actually run the software or create the software that's going to run on the device. What kind of software is that going to be? Then you also, on the cloud side, need to be able to handle things like, say, you're creating telemetry data and you're continuously sending that to the cloud. What if there's kind of the wireless is kind of flaky? How do you handle that sort of thing? Also, how do you handle the stream processing? Like if the device sends data to the cloud and the cloud's not ready to actually process it, how do you deal with that? So we're going to actually deal with that by using a message queue. So a message queue is going to take a message from our device. In this case, it's going to be telling us temperature data in a message. And that's going to get stored in a queue until the stream processing system is ready. And then the stream processing system is going to take that data from the message queue and then write that to our time series database. And then we're going to store our state data and metadata in a state database. So I'm going to go through all of these and actually kind of fill in what each one of these are as we go along here. So the first thing I want to talk about is the actual device. So for my little application, I'm going to be using a BeagleBone. And so that's this device over here, if I can switch over. So I have a little device over here. This is a BeagleBone with some temperature sensors on it. I'll show you that a little bit later. So going back, the BeagleBone is an open source mini computer that runs Linux. It's very similar to kind of a Raspberry Pi, if you're familiar with that. It's developed by Seed Studio, or this particular one is developed by Seed Studio. It's an open source one, so if you wanted to, you could print these circuits out yourself if you wanted to. But it comes with these really cool connectors, these I2C and RS-232 connectors, which make it easy to kind of plug in some devices without actually having to solder them. And Seed Studio also makes some cool Grove sensors. which you can actually plug into the BeagleBone and then actually get it to connect and work without actually having to solder it, which is pretty cool for doing some prototyping. So here I'm going to use this analog to digital converter and a temperature sensor. So the temperature sensor creates some analog data, and then that's going to get converted to digital to actually go to the Grove, or to the BeagleBone. Sorry. The next thing I want to talk about is the software. So I'm going on the BeagleBone. It runs Linux, and so what I'm going to do is I'm going to create an application on Node.js. And there's this really cool library called Johnny 5, which is a JavaScript robotics and IoT platform. And it's got a really cool logo. And yeah, I picked it for the logo. But it's really got a really cool interface, and it's written in JavaScript, and most people kind of know JavaScript. And JavaScript is a heck of a lot better than writing C++, so that's what I chose. So Johnny 5, like if you actually write an application, it kind of looks like this. It's just regular old JavaScript, so you can just require the Johnny 5 module, and then I'm also using the BeagleBone IO module, which is used to connect to the interfaces on the BeagleBone. And then you can kind of pass the BeagleBone object to Johnny 5 to create a board object. And then you can say, you can set a onReady signal so that, or a function so that when the board is ready, you can actually run some code. So you'll set up the board, and then it'll set up all of the connectors and things like that on the board. And so when it's ready, then you can actually run the function. So that's really good, so that you don't have to like deal with timing and things like that for when you're actually running your application. So the next thing that I'm going to do is I'm going to store the state database state data in Firebase. So you might have heard about Firebase from the keynote. Firebase is a platform for creating mobile applications or real-time applications, especially mobile. But what's really cool about it is it includes this like NoSQL backend, which is kind of JSON based. So it looks really a lot like a JSON object and works like a JSON object. So it has kind of a tree structure inside of it. And so I'm going to be using this to actually store the state database or state data. So as the application is running, it'll update the state data. So Firebase, you can kind of connect to it like this. You require the Firebase module, and then you can authenticate it to it using the Firebase token generator. And then once you've authenticated, you can create a reference. You'll have a reference to the database, and then you can use that to set objects to the database. And right now, I'm just setting a whole JSON object to a particular key in the database. And this is just going to contain all of my sensor or my state data for the device. And so as I'm kind of looping through the application, as it's reading data from the device, it'll actually update the state as well. So for the backend part, for the telemetry data, I'm going to be using Cloud Pub Sub. So this is our messaging queue that we're going to use to take the telemetry data. We're then going to process that data using data flow. And then we're going to store the time series data in Cloud Bigtable. So I'll talk about each one of these in turn, but what's really great is that each one of these will scale to handle a large amount of data coming into them. So each of these independently scale, which will allow me to handle many, many devices in the future. So Cloud Pub Sub is just our managed fully timed messaging service. So it basically just acts as a messaging queue. So you can put data in and into the queue, and then on the outside of it, the data flow will actually take messages from the queue and then process them as it's ready. So this will do a lot to help kind of smooth out sending data from the device to the processing system backend. And data flow is kind of a unified programming model and managed service for doing streaming data. So this is very similar to something like Spark or Hadoop, or it's kind of like an in-between between them, but it's unified so that it works with streaming or batch models.
So in this case, we're going to use it for streaming, but you can also use it for batch. Basically, what you do is you create kind of a pipeline with a bunch of different steps, and each one of those steps you define how to handle one piece of data, and then it kind of handles how to scale that up and parallelize that for you. So we'll look at that a little bit later. And then lastly, Cloud Bigtable is a NoSQL database that Google uses internally for a lot of our core services like search and analytics and maps and Gmail. Essentially what it is a key value type of database, but the keys are kind of sorted in kind of lexicographically. So that's great for things like time series data. It's also maps from one key to a row of data, so you can have multiple values. So each of those are in a column. So what we can do is you'll have a key, and then you could map to like any number of pieces of sensor data. In our case, we're just going to be using temperature data, but you can imagine that you could have many different types of sensor data. So on the application side, in order to send a pub sub, we're going to create our thermometer object. This is a Johnny5 object, which will read data from the Grove sensor every 5 seconds. And then basically we'll set a callback on this thermometer. So when there's data available, it'll run this function, and we'll just publish that data to Cloud PubSub. So here I'm sending the data as with our device ID and a channel and a timestamp and the actual temperature data. So this just goes into Cloud PubSub as JSON data. And then on the data flow side, here we have like a couple of things to just set up data flow to be able to read from PubSub and from Cloud Bigtable and write to Cloud Bigtable. So these are just basically objects that I'm going to create from some command line arguments to tell data flow what topic, PubSub topic I should use, what Bigtable table I should use, and what Bigtable cluster I should use. And then we'll actually create a data flow pipeline. So this pipeline is just, you create an object. This is Java code. So we just create a pipeline from our objects or from our options. And then we're going to create a 3-part pipeline. One is just a built-in step that we can use for data flow. This is PubSub to read from PubSub. And then we're going to read that using a JSON coder, which allows us to read JSON data. And then we're going to apply this mutation transform, which is a transform that I wrote in Java code. And then at the end, we're going to write to a particular table in Bigtable based on the options that we had. So here's how I'm going to write my actual mutation transform. So I can write code for Cloud Dataflow that will define how to process each record that comes in to Dataflow. So we're going to be reading from PubSub. So each message that comes into PubSub is going to be passed to my transform. And then this process element is going to be called in order to actually process that. So going through that, we're reading from the JSON object that was passed in. So we're reading a single JSON object and all of the fields, device ID, channel, timestamp, and data. And then we're going to create a row key for Cloud Bigtable using our device ID and the timestamp. And then we're going to create a put request for Cloud Bigtable. And so now I'm just going to loop through the keys that were sent in the data. And in this case, it's just the temperature data. But we're going to just add that column to our row. And then finally send the put request as output from for our transform. So that's going to basically just change our JSON object into a put request for Cloud Bigtable. So now that I talked a little bit about that, I'm going to jump over to actually show you a working example of that. Let's see.
So first, I want to start my application. So here, I'm on my BeagleBone, and I'm going to start my Node.js app. This takes a second to start up. But once that starts up, we should be able to go into Firebase. I have my Firebase, this is actually the old console here. So once that actually starts up, we should be able to see that the state data starts getting updated into Firebase. And you can kind of see from the management console in Firebase which fields are actually getting updated. So here we can see that the status of the sensor is pending. So once that gets starting, we can see that it's now reading. And the temperature currently is a nice 20 degrees Celsius. And I have this set up to read every 5 seconds. So this timestamp will get updated as well as the temperature. So now that I've got that, I'm going to go ahead and, this is actually reading data and sending it to PubSub. So PubSub is kind of queuing up that data. And then I can actually start my data flow pipeline. So data flow, basically, in order to start it, you just run it like a regular Java program. So here I'm just going to use Maven to start it up. But there's also a Eclipse plugin that you can use to run data flow jobs directly from Eclipse. So if you're an Eclipse person, then that's definitely something you should look into. But I'm kind of a command line junkie, so I like to use the command line. So if you run this will actually start up data flow, and data flow will actually start up some VMs on GCE or on Compute Engine in order to actually run your processing. And that will kind of scale up and down based on the number of messages coming into PubSub. But it takes a few minutes to actually start at those VMs. So I actually have one running here. That's the kind of the cooking show way of doing things. But so I've got one already running here. So let's go and look at data flow. So if you go into the Cloud Console and you go to Big Data and to Data Flow, once you've created a job, you can see it in the list of jobs in data flow. And then if you click on that job, you can actually see a visualization of the steps within that job. So here, these are the 3 steps that I created in my Java program. So here it shows the PubSub read. This is the Java transform that I wrote. And then this is the part to actually write to Bigtable. So that you could have any number of permutations of how you actually create a data flow pipeline. But I just kind of created a simple one here. And it doesn't have to be linear like this. You can actually have, from my transform, I could actually have a step after it to write to Bigtable, but also write to, say, BigQuery. So BigQuery is another kind of analytical database that you could use to store data and then run SQL queries over it. So you could definitely do things like that. That's kind of one of the really great and flexible things about data flow. So just going back, and then I have a little sort of visualization of the data. So if I go over here, so this is a little app that kind of will query Bigtable in real time to actually check to see the temperature currently. So this is pretty boring. It's just basically staying the same. But if we go over here and we kind of squeeze this with my finger, hopefully it should actually make the temperature increase here. So I'm pretty hot today, I guess. 25 degrees. So you can kind of do these sort of real-time applications as well. So this is actually will show you kind of that the data is actually going through all the way through the whole pipeline and actually ending up in Bigtable, because we're actually doing a Bigtable scan here to get the data. So I'm going to jump back to the slides. So kind of just to wrap up, I wanted to go through and make sure that we checked all the boxes for our requirements for our application. So we were able to read the temperature data from the device. We were able to handle a large number of devices because each of the backend pieces, PubSub, Dataflow, and Bigtable, are all able to scale and handle a large number of devices. We're also able to like pull out and analyze that data using Bigtable. We can do that in either by scanning Bigtable, or we can develop, like I said, other methods like writing directly to BigQuery and then doing SQL queries on it and doing analysis that way. And then we were also able to manage the info and status of each device using Firebase. So these are a number of different, how you could like kind of put together different parts of the cloud to actually create a full solution for managing IoT devices or managing data.